Hey everyone, welcome to this explainer. Today we're tackling something that literally every developer, engineer, and tech enthusiast needs to have on their radar: how modern applications get hacked. Our main goal right here, right now, it's a mindset shift. We're going to step away from the traditional perspective of just building out cool features and instead figure out how to anticipate real threats. We're not doing abstract theory today, we're looking at the actual practical ways applications get compromised out in the wild. By the time we wrap up, you'll know exactly what hackers are looking for.
Okay, let's dive into this. We've got a quick roadmap to break this whole thing down. We're going to cover the attacker's mindset, defining the attack surface, 7 common attack vectors, the anatomy of an attack, why traditional defenses fail, and finally, the secure coding solution.
Starting right off with Section 1, the attacker's mindset. Think like a hacker. And this brilliantly illustrates the fundamental difference between the builder's perspective and the breaker's perspective. It's so crucial to get this. As developers, we're usually obsessed with the features. We're asking, does this work? Does it solve the user's problem? But attackers, they are completely on the other side of the fence. They're looking at it thinking, well, what happens if I send some completely unexpected input? What if I just skip step 2 and jump right to step 4? Or what if I mess around with this ID in the URL? They don't care about your happy path. They are hunting for the edge cases, the tiny overlooked details, and honestly, the assumptions you had to make just to meet a deadline. To a hacker, every new feature is just a new playground.
Which brings us to Section 2, the attack surface, defining the boundaries.
So, looking at the architectural reality of modern apps, every single new feature you add is actually upping your risk, right? Your app isn't just a login box and a search bar anymore. It's this sprawling fortress. The attack surface is literally the sum total of every single point where an attacker can poke at or interact with your system. We're talking APIs, URLs, cookies, HTTP headers, WebSockets, even the exact timing of your error messages. Basically, any input that crosses a trust boundary from the outside world into your app is part of this surface. So if you want to reduce your attack surface, think of it like this. Just don't build unnecessary doors into your fortress in the first place, because every new endpoint, that's a brand new door.
Let's move to Section 3, common attack vectors, 7 critical flaws. Now, what's really interesting about this is how the most devastating breaches usually come down to incredibly simple logical oversights. Take injection, right? The absolute granddaddy of them all. If you just blindly trust user input, an attacker can literally type OR 1 = 1 straight into a login box. And since that statement evaluates to true, the database just waves them right in. No way, right? Then there's broken authentication. No rate limits, attackers will just run automated credential stuffing bots to brute force passwords all day long. And check out broken access control, specifically IDOR, Insecure Direct Object Reference. This is wild. Someone is logged in and they just tweak the URL from account 123 to 124. If you aren't strictly checking their authorization, bam, you just handed over someone else's bank details. Finally, expose data. This is just basic stuff like failing to encrypt passwords or, accidentally leaving your .n files exposed on the public web for anyone to grab.
But here's where things get really, really tricky. You could write flawless, totally secure code. You validate every input. But what if the libraries you're importing are a mess? This quote nails it. Your code is secure, your libraries might not be. Think back to December 2021. Remember the whole Log4Shell nightmare? Log4j was everywhere, a practically universal logging library. And because it had this one critical flaw that allowed remote code execution, the fallout was global. It was absolutely catastrophic. Hackers are constantly scanning the web for these exact kinds of known vulnerabilities in popular packages. Let's see how this builds out the rest of our vectors. So we just talked about vulnerable dependencies, which totally open the door for supply chain attacks. But look right here at misconfiguration. Seriously. How many massive databases get breached just because somebody left the default admin password as admin or left an AWS S3 bucket publicly readable? Honestly, it happens all the time. And then API exploitation. APIs are absolutely the new frontier for hackers. A lot of times developers spin up an internal API, assume nobody on the outside can even reach it, and just totally skip authentication. Or they get hit by mass assignment, like the API blindly accepting a JSON payload for user registration that casually includes is admin true. The point is, even perfect code gets totally compromised by a sloppy server config or an unprotected API endpoint.
All right, on to Section 4, anatomy of an attack, the 5 steps of a breach.
Now we are going to see how all these theoretical vulnerabilities actually get chained together out there in the wild.
And I want to walk through this with a bit of urgency. So, step 1 is reconnaissance. The attacker is quietly mapping out your tech stack and finding endpoints. Step 2 is scanning. They start probing those exact endpoints for the vulnerabilities we just covered, looking for exposed files or a nice juicy injection point. Step 3, exploitation. They break in and get initial access. Maybe they drop a web shell. Step 4 is escalation. They start moving laterally through your internal network trying to get admin privileges. And finally, step 5, exfiltration. They grab the sensitive data, wipe their tracks, and completely vanish. Listen, I want to be super clear on this. This 5-step process, it's not some crazy Hollywood movie plot. This is literally just a Tuesday for a penetration tester.
So, how are they doing all of this so incredibly fast? The hacker's toolkit. Things like Burp Suite and OWASP Zap. These let attackers intercept and tamper with your HTTP traffic in real time. Then you have SQL Map, which completely automates SQL injection. You just feed it a target URL, and it basically dumps the entire database for you. They're using Nmap for network scanning, Metasploit for these off-the-shelf exploits, and Shodan. Shodan is literally a search engine designed specifically to find vulnerable internet-connected devices all over the globe. The barrier to entry here has literally never been lower because these tools are insanely powerful, mostly free, and they automate almost the entire attack chain for you.
Which leads us to Section 5, why traditional defenses fail.
So the crucial point we need to address here is this really dangerous myth floating around. A lot of folks think you can just buy an expensive security product off the shelf and it'll magically patch up your bad code. No way. A traditional network firewall operates way down at layers 3 and 4 of the OSI model. It just cares about IP addresses and ports. But your web application, that's living all the way up at layer 7. A firewall might perfectly allow traffic through port 443, but it has zero clue if that HTTPS request is just a normal user logging in or a massive SQL injection payload. Antivirus isn't going to save you from an IDR flaw in your API either. These traditional perimeter defenses simply do not understand application layer logic.
Finally, we arrive at Section 6, the secure coding solution, learnable defenses. Okay, let's just take a breath. I know. We've just covered a terrifying list of ways your hard work can get totally ruined. But I promise I have some genuinely good news for you. Every single attack vector we've talked about today has a corresponding, highly learnable defense. Secure coding isn't magic, and it's not some innate talent you're just born with. It is a completely repeatable skill. Things like strict input validation, that permanently stops injection attacks in their tracks. Proper authorization checks on absolutely every single request, say goodbye to IDOR and privilege escalation. Adopting secure defaults and actually auditing your cloud configs, that puts an end to misconfiguration breaches. You actually have the power to lock all of these doors.
So I want to leave you with a bit of a provocative question to wrap up this explainer. Is your code actually secure, or is it just functioning? Because as we've seen today, just functioning is exactly what an attacker is relying on. It is time to start adopting the attacker's mindset. Stop only building for that perfect happy path. Start actively hunting for those hidden doors yourself and empower yourself with the secure coding skills to lock them down for good. Thanks so much for joining me today, and keep learning.